Let's take a look at the drawings in the back, which are the original plans for the building that we're going to be putting together and then your studio project happening in. This is only 11 sheets out of maybe 80 or something of the whole set, which includes mechanical, plumbing, architectural, but we just didn't need those for putting together an approximate model of the building that we can then do your work inside. And actually, as built, it's a little different from what's here. We're just going to go with what's here because we have the drawings. And then when we go down to look at it, we'll take our own plots and mark them up as we need. There's sort of a colonnade of columns outside that support the main building. And then in that, there's this glass box for the first floor. So it looks like the building is sitting up off the ground by 15 or 18 feet, something like that. This building, as we will see, just works entirely on like a 7-foot grid that he used in other buildings, 7 or 7'6". But his whole idea with the way he laid out buildings was, I'm leaving as much room as possible so you can do whatever you want, as opposed to micro planning each suite or any of that kind of stuff. Frank Lloyd Wright, by contrast, would design your rugs, your furniture, and your silverware. You know, right now, this can easily switch from being a law firm here to and engineers over here to the other way around or subdivide it. And then each floor has its central core with stairs, elevators, ventilation, and bathrooms. Oh, just all of that. And they're perfect copies of each other. So one thing you'll find that worked well for his office and it works well on Revit is that once we've done this on the second floor, it's just window it, copy to floors 3, 4, and 5. And just there, we don't have to redraw them again, right? Reflected ceiling plans, see what the intent was, just put anything wherever you want. And the ceilings are high enough, they're probably, I guess they're 10 feet, something like that, that lots of light up above just washing down. And I mentioned this before, you sort of need that much to counteract light coming in from the west. Anyway, so what we're going to be doing today is laying out the building grid with its funny numbering system, the floor levels, and the exterior columns, putting all that neatly together. Who all here has a scale rule? Just one. Well, good, because we just bought one for each of you as a present from the, this is your tax dollars at work. As a rule, you're really never supposed to measure from a drawing because the idea is that anything that's an important dimension is already in the drawing as a dimension. But sometimes you just want to know, okay, about how far is it from here to here? And that's not laid out anywhere. You just put the scale ruler down and say, okay, 48 feet or 49 feet or whatever it happens to be. So don't they like give you a stethoscope when you get your medical degree? Well, here are your own scale rules. And I would say put your name on them. Maybe on the 1.5-inch scale, there's room for a name. One of the reasons you can't always scale off of prints is that as they're put through whatever process they are, sometimes they're skewed. Sometimes the paper is stretched by whatever wheels are pulling it through. So you can use this for approximate distances, but if you're trying to get like super close, it's not the tool to use. If somebody wanted to know that, it would have been called out specifically exactly how big that was. So how far apart are the columns? Like from one column, center of one column to the center of the next column. It's the same. Well, let's check and make sure it's the same vertically and horizontally. Go to the center line. What you got? 42 each way? Sounds good. And one of the nice things about his drawing, this building, is everything is on this 7-foot grid. So you can really just count 1, 2, 3, 4, 5, 6 times 7 is 42. I mean, it's just like you'll see in some of the diagrams, he's dimensioning stuff to the 16th of an inch. So it's like somebody's really paying attention to it, but we will be playing a little faster and looser with some of them. Yeah, and why 7? I don't know. He also sometimes used a 7'6" module, just a little bit bigger. And do you all know about Corbusier's the modular? You know that? Well, that's 7'4" is how that works out. And maybe Mista said, I'll just do a little. I'll go to 7'6" just to I don't know what his reason for that is. Let's see. We're talking about the main grid, and then there's a subgrid in there. Eventually, we're going to start wanting to look at these drawings, or we would if we were building the place, to look at drawings drawn at a larger scale, a more detailed scale. And here's the stair detail is done at a 1 inch equals a foot. Find 1 inch equals a foot. You'll just say 1 over here. And it's Barbie scale. just so you know. So tell me how high a typical step is. Well, yeah, measure vertically. Okay, so there's the zero, and you can count down. You can count down inches this way, or you can slide it to there and count up from that zero. So 3, 6, 7 inches. Which brings up something else, which is it could be that once you've drawn these through floors, architect would come back and say, "Oh, we put that at 15 feet. I would like it to be 17 feet." If it was a matter of feet, you'd be asked to erase it and redraw it in the right place. If only a matter of inches, maybe you could just change the text that said how high the floor levels were and put a revision bubble in there. And the point is, dimensions always, and dimensions and notes always overrule what's drawn. Anyway, let's go see what it takes to put this together. Conceptually, what we're doing is building like a three-dimensional framework to place our building in. Unfortunately, this building is just, that's all it is, a three-dimensional framework turned into 3D stuff, which are levels, which are horizontal finite planes. So the levels that we create will have only extend so far in each direction, but they're always horizontal. You can't tilt them, you can't do anything like that to them, and use them for the floor levels as well as for any other important heights throughout the building. Like if there's a slope roof that has a continuous parapet, you might have a datum, a level set for the top of that parapet so the walls could come up to that instead of up to the roof. Going down, you'd have probably several levels for the bottom and the top of the foundation and footings that the walls get built up. So those are the horizontal divisions. And then grids are finite vertical planes, usually corresponding to structural center lines, but not necessarily. And these can be curved, they can be straight, they can jog, whatever sort of the structure is doing. And so together, we're going to start a new file using the commercial default one. And I'm picking that for a couple of reasons. One, it comes with all the walls and wall types that we're going to need. It's got the curtain wall and that kind of stuff. We'll just start with that. Open. Okay. And it comes with some overhead I want to get rid of. It has levels we don't need. It has views we don't need. It has sheets that I would like to create all these ourselves. So we're not trying to figure out how all this stuff works. We're going to create our own to make that correct. And what I like to do is end up with, in terms of floor plans, I just want level 1 and the roof and the site plan. That's all I want to see. So I want to get rid of the footing level, get rid of foundations, get rid of roof framing, get rid of top of footing. We'll create new levels as we need them, but I don't want to have any preconceptions going on. We'll keep all the elevations. I think we'll just get rid of all these door, room, and window schedules. I'm just hitting the delete button here. We'll create our own. And then I want to get rid of all the sheets. Let me see if I can do shift click and delete. No, just got to delete them one at a time. Just to clean this up, so we'll be making our own project with just the views and sheets that we need. So floor plans, level 1 roof and site plan. Ceiling plans, level 1, 4 elevations. That's all we need to have, and no sheets. On page 1 is where do we get this information? We have the drawings right here, but as we'll find out, they aren't necessarily correct. Stuff has happened to that building in the last 50 years, and we'll want to be documenting that, especially as it affects any spaces that you guys are working in. So plans, we'll be taking photographs while we're there just to check. Are the lights the same? Are the window mullions the same? What is the spacing on those in terms of how we're going to be placing furniture or stuff like that? That should be LOJIC, the logic maps that we used for Farmington. That's another place to get information. We'll be taking our own field measurements and photos and sketches of stuff. For instance, at the foot of each window all the way around is a HVAC register and I want to be able to measure those. Articles, videos, interviews. We need to make sure we have the structural columns, how big they are and how far apart they are. Major walls, just verifying that they're where our drawings say they are, especially the center cores, and then making sure that we get the floor-to-floor heights correct. I'm pretty sure they're specified to the nearest half an inch over there in the drawing, but we should go in one of the stairwells and see if that's actually what they are. And you would definitely do this in the building for which you did not have drawings. And then in addition, we want to measure the floor to ceiling heights, check the glazing, mullion center lines, that kind of stuff, because things could have been added or deleted or changed, various redos over the past 50 years. And then in terms of laying this out for, listen, not for this building, but for another building, it's helpful if there are repeating modules, the 7-foot thing that we see in the American Life building. Are they rectangles? Are they squares? Are they a golden ratio proportion? What's determining that? Is there an underlying order to things? And if so, what are those? What are the proportions? What are the spacings? Does this spacing relate to these, just to understand the order behind the design, as opposed to just haphazard stuff anywhere you want? A project that doesn't have an order runs the risk of just being chaotic, which is not to say you have to have everything on a 7-by-7-foot grid from one end to the other. So, grids. To start to create these grids, we can basically put them anywhere we want. If we go down to reveal hidden elements, right here are 2 controls that determine where this project is if we want to locate this on a map or in relationship to other buildings. It's sort of like the 0 point in AutoCAD. So there's 2 of them. One is locating it horizontally and vertically, like above sea level. Essentially, it's GPS coordinates. And one is determining how it's oriented relative to north. But we're not concerned with those at all as interior designers, as a rule. Somebody else's job. We're going to be treating this as north up here, so that when we're starting to set our sun angles, we don't have to sort of do rotations in our head to be thinking like, say, north is over here. So if we're working from that drawing, I want to set up the grid lines running north-south first. So they'll be going like from here, boom, 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 like that. And this is just with architecture grid. And you'll see we can do straight ones, curved ones, multi-segment ones. We're doing straight. Out here, I'm just going to drag it down like this. Just our first one. I don't know how big. Nice thing about Revit is if it's too short, we can make it longer. If it's too long, we can make it shorter. As I drew that, it put the grid label at the last point I picked, not on the first one. But any of these grid lines, we can select it and choose to check display to see the bubble up there. So I'm going to do that. And then I'm going to copy this over. Oh, how far apart were they? 21, 42. I think we better go look. But let's take a look at what they're actually measuring, because it might not be just the structural columns that they're doing. So, field trip. Should we just station somebody back here to answer our questions? Okay, so what we did was, it's going to end up being, this is north, so it's this guy right down here. So it's that measure there to here, yeah. And this is at 1/8 inch equals a foot. 21, okay. So we have 21 here, so 42 is from there to there, but we're actually also doing an intermediate one as well, because there are other things that start to line up with that later on. So we just did this one, because this is north. So we're going to renumber that B and then copy it down to H, B through H. Now this guy, we don't want that to be called number 1. We want that to be called number B, because it's over there. So you can click on the text and just put in B, and it changes down at the bottom end. It knows what it is. And then to start making the rest of them C through H, let's just use the copy command. Copy. We can click anywhere and drag the direction where we want to go and type 21. And again. And you see it took B and made it C and made it D. So I'm just going 21 each time. Oops. And I wasn't dragging straight horizontally that time. So it really works if you just put this way out past where it needs to go and then let go of the mouse. It'll just keep that 21 foot going horizontally. B, C, D, E, F, G, H. Okay, and now we can do from 5 through 11 going up. Since my last one was H, when I put this in, it'll be like I or something or other. But which brings up another question, which is when you're doing these in the real world, you never use the letter I, the letter O, or the numeral 0 by itself for any of those because they just look, this can look like a 1, an O can look like a 0. So you do A, B, C, E, F, G, H, J, K, L, M, N, O, N, P. We're just leaving out I's and anything that looks like anything that can be mistaken for the other type of symbol. So this time, let's say that I want to have my numbers going on this side. I'm going to start it doesn't matter which side I start on. It's just that architecture grid, if I start over here, it'll put the bubble at this end. Revit will create a bubble labeled I, but we won't leave it that way. And I'll make that be number 5. And then I'll copy those up 21 feet at a time. I'm just going to go all the way up straight, let go of the mouse. 21, 21, 21. Now, eventually, we're going to lock this just so we don't actually accidentally move them around. But before we do that, I want to get our columns, our outside columns will be right here on these corners. I want to get a little more space, a little more distance from the building until we hit the bubbles. I can grab this point right here, and that'll drag them all up. Click one, grab the button where the line hits the circle and pull them straight down. And then a couple of things. I would like to get my elevation markers outside all this. So I'm just going to pick it and drag it out. Pick it and drag it out. But if for some reason I wanted my elevation marker to be right on this E line, and I wanted it right there, for instance, maybe I'm running out of room on the sheet, who knows? So I sort of have to move this E. And you probably do this by mistake more often than not. But if you pick this guy, see that little cut mark there? That's going to let you pull the mark away without moving the grid line. And now if that's what I wanted, I can move that down like that. Or if there's a tree there or some other device. We don't need to do that here. I just want to show you what's going on. So if this ever happens to you by mistake, you can pick this again, pull them back vertically to each other. Okay, so did that work out to getting for 5 renumbering itself up to 11? All set? Okay, good. And now just to get a sense of where this building is going to be, I want to place the 4 corner columns to see them. We're not going to do the true structural columns with the I-beam or whatever inside there. We're just going to use what's called an architectural column. This is sort of the shell, the clean architectural shell around the ugly structural stuff that would have to happen in there. And that's going to be an architecture column. It's not a component, it's a column. And we're going to pick column architectural. As it turns out, built into this template is this rectangular column 24 by 24. So it's every other one. I'll go down. Oh, there we go. Okay. So we got 4 columns down that left-hand side. There's 16 columns altogether. We could keep doing that to each of these grid intersections. But at this point, it'd really be easier just to grab all 4 of these and copy them over 42 feet at a time. So I'm just going to window them to select them all, and then copy. And I can really pick anywhere I want on one of the vertical grid lines, as long as I just go straight horizontally across. I don't know if you noticed, but the default setting for inserting columns is to have move with grids checked, meaning these guys now know that they are supposed to be on a grid and at an intersection. Actually, they're supposed to be attached to two different grids, each of these. So if we move the grids, we move the columns as well. If you placed a column accidentally just sort of here and miss that point or whatever, we can move it, move. It has a center point right there. We can click to that midpoint and then come down here and click to this intersection right there. So we can get it. We can get that one back onto a column module as well. So it's not lost if they came off. Okay, so that will suffice for our grids. Let's look at what those look like in elevation. If we go over to east, our east view, we can see that I've got some little tiny short columns that are going clear up to the roof. Let's move the roof up where it needs to go. Alex, can you tell us the elevation of the roof back there off of one of the elevations or sections? And it's going to be the main roof, not the penthouse roof. It's toward the end of the set. 71 feet, 9.5. Got it. Okay. So here in an elevation view, let's go over to our roof level, click on the 12'8" or whatever that is, and change that to 71, 9.5, 71 feet. I'm doing 9.5 for the inches. 71 feet, 9.5. And up it goes. And I see here in this elevation view that I've got two levels down here, structural levels that didn't have floor plans associated with them. So they didn't get erased over here, but I don't want these two guys. We want to be starting right from level one, not have these to confuse things. So I'm just going to delete them. Just too confusing. By default, our grid lines only came up as far as we had defined the building volume to that point when the roof was, down at 12 feet. So I'm going to pull these up again, just grabbing by point and pulling those up so they're up past the top of the roof and out of the way of what we'll be modeling. Okay, so here are our major and minor column grid lines. Now let's create new levels. So we got level one is right here. We can create new levels from scratch or copy one already in the model. From scratch, we can go to architecture, datum level, and then just create a new level right here by clicking where you want it. Or I can just copy this one using control drag. We'll be making 4 copies, 2, 3, 4, and 5, 4 new ones, which I'll make more or less evenly spaced across here, and then we'll worry about the dimensions later on. So I'm just going to use control drag and just drag straight up to create 4 new levels. And Christian, since you're back there, would you tell us what those elevations are for levels 2, 3? I'm sorry, I have to renumber mine. I made that little level 2 briefly. That sort of reset the counter. So I need to change this one to level 2. This one to level 3. This one to level 4, and level 5. Okay. What's the elevation of level 2? Should be on one of the elevations or the section drawings. 19.4.5. Let's keep going. Number 3, 26.10.5. Number 4, 44 foot 4.5. Number 5, 56 feet 10.5. Got it. Thank you. Back to work. Level 1, 2, 3, 4, 5. We already have the roof up there. Level 2 will change to the 19.4.5. 19 feet 4.5 inches. I find it's easier to enter just 0.5 than the space and the 1 and the slash and the 2 and the all that. So this is when I jogged by mistake. Level 3 is 31 feet, 10.5 for 44 feet, 4.5, 56, 10.5. And then 71.9 up to the roof. Okay, I'm going to drag this out a little farther. Works just the same way horizontally in these views as it does in the plan views. And I'm just going to put a dimension string along these just to understand what's going on here. So DI is the dimension tool. Just clicking up and up and up. And then out in space somewhere when you're done to finish. So there's the 19.4.5. And then we have 3 at 12.6 and 1 at 14.11. As you can see, the 5th floor windows are higher than the ones below, and the spandrel above them is a bit wider as well. Okay, so there's that. Let's look at what this looks like in 3D view. View 3D view, default 3D view. So you can start to see that three-dimensional framework showing up and then the actual building components attached to it. When we select or even just hover over a level or grid line, the plane that it determines is highlighted. We can see that I've moved the grid bubbles up in one elevation view, thus making their planes higher, but not in the other view. In the north-south views, it's not. So I'm going to go over to north, right, and pick these and drag them up. So we can start to see that conceptual 3D framework starting to show up. So far, we have level 1 and we have a floor plan for level 1. We've created these other levels, 2, 3, 4, and 5, but we don't have plan views yet for them, which you're not going to probably need that for your project, but it would be nice to have them here anyway. And the way we do that is go over to View, Plan Views, Floor Plan, and it will give us a list of the levels that don't yet have a floor plan associated with them. And I think we can just pick level 2 and say OK. And now it gives us a level 2 floor plan and makes it the current one. It looks just the same right now because there's nothing there yet to deal with. We're still just looking at columns and grid lines. But the point is we wouldn't see the grid lines if they had just been left only like 10 feet high. If we drag these guys, let me just do that. We drag these back down to here and go back to level 2. We wouldn't see them. Those planes don't yet come up through this zone of space yet. I'll Control Z to undo that change. Well, we're about done for today, but I do want to put up what's called the subgrid, which is the 7-foot module that we've been working with, the slightly lighter set of lines here. Let me put these across here as well. Because so many things inside the building are going to line up on the 7-foot grid that I want to be able to see that, but it's not numbered. There'll just be grid lines that are in place that we can use them to draw a wall or locate a staircase or something, but we won't actually be giving them numbers to do that. So what I want to do, I'm going to copy this over 7 feet. Copy 7. This is going to be a new type. So I'm going to edit type and duplicate it. And I'm going to call it no bubble. Okay. So a new type called no bubble that then I'll say the symbol, I'm going to say there, no symbol on the end of it. So it's not going to have a bubble, and I want it not to be black, but I want it to be, let's say, light gray, just so I can see it, but not have it be so as strong as other guys. Okay. and then apply. Okay. Okay, so just the way that we can change the qualities of a piece of furniture by changing its properties, so we can, by creating a new type and change its type properties, we can do that for this as well. So this is this is one type of grid, and this is another type of grid, which will be handy because we can control their visibility separately. And I'm going to copy this over 7 feet to get it in there. Copy, 7 feet. And then I'll just copy these two every 21 feet this way. So select, control click to select. And I'm going to copy these guys just straight across like this. And this is what we can use to align the ceiling tile and the floor tile and everything else in this building. Same way, I'm going to copy this down 7 feet, make it the same type as this. Copy 7. And then use the match tool to match the properties of this to this. MA, this to this. So no bubble, light gray. And then copy this down 7 feet. Seven. And then copy these guys down. Copy from here to here to here to here to here to here. Now, the last thing I noticed was out on the floor plan or the site plan, I can't remember which, we have our building out to the 4 corner columns. And then 7 feet outside of them, all the way around, is the granite floor that extends right on into the building. Outside of that is some sort of lesser material for the whole Belvedere. So I would actually like to copy one of my grid lines 7 feet outside of what we've got, just to be able to locate that precisely. We're going to get awfully tired of 7 feet by the time we're done with this, just saying. So I'm just going to copy this guy. Regrettably, you can't offset grid lines. You just have to copy them. Copy 14 feet. Same down here. CO 14. CO 14. So I think what we'll do here, without paying attention to the, making it marble or granite, I think it's granite, whatever it is, we're just going to put a 4-inch floor here, just to sort of get ourselves grounded. So I want to be in my level 1 plan, because it's going. This is level 1. This is what defines that. Go to architecture floor, and we'll just say 4-foot concrete slab for the time being, 4-inch, and I'm just going to do it from that outside one to there, 7 feet to the outside of our gridded columns. Say okay. Take a look in 3D. So that'll give us this, which I think is a good place to leave this.